viewers to another episode on ASYOG 12 exams. So in this episode we are starting to look at section B of the 2021 Internal Science paper 1. So let us start with looking at question B1. The following graph shows a distance time graph of a bus moving from town A to town B. So we have the graph. On the x-axis we have time in hours moving from 0 to 5 hours. Then we have distance in kilometers on the vertical axis moving from 0 to 60 kilometers. Question A. What is the total distance between town A and town B? So the question is requiring us to find the total distance. So what we need to understand for us to find is basically since this is the distance when the graph is flat, like at this point and this point, the bus is not moving, it's stationary. So the bus stops moving at this point at 4 hours exactly. So at this 4 point the bus is not moving, though the time is moving. So at this point the bus has reached its destination, though we continue recording time. So what we need to find is what's the value on the vertical axis at that point. So we know that from here to here there are 10 subunits. If you count these are 10 subunits, and these 10 subunits are equivalent to 20 kilometers. So meaning what we need to do is 20 kilometers divided by 10 subunits, we get basically 2 kilometers per subunit. So now what we notice here at this point at B, we have one subunit before reaching 60. So to find the distance to be 60 minus 2, which is basically 58 kilometers. So 58 kilometers is the value at this point. So that's basically the distance between town A and B is basically 58 kilometers. We move to B. The bus stopped at a station between town A and town B. For how long did the bus stop at this station? So basically the bus stopped at this point and this point. So between these 2 points the bus stopped at this point. At this point the bus is not moving and it has reached the final destination, so it's not continuing. So the one point of a stoppage is the one that we need to consider. So what we have is basically, again, we have 10 units here, and this 10 units gives us 1 hour. So basically 1 hour, how many minutes are in 1 hour? We have 60 minutes. Divided by 10, we end up with 60 minutes per subunit. So per subunit we have 6 minutes. So now what you notice here in this case is starting 2 points after subunits, then going, these are 8, so that we get 10. So it stopped for how many? 8 subunits. So it's 8 times 6, which should give us basically 48 minutes. So the car only stopped for 48 minutes, then proceeded with the journey until it reached at this point. At this point the journey has finished. We just continue recording the time. So the car only stopped for 48 minutes. Or basically what you are saying is basically 0.8 hours. But if you write 48 minutes. C. Calculate the speed of the bus between town A and the first station. So the first station is happening here, so we need to find the speed of this. So this is just basically the slope, and we know that at this point this is 30. So kilometers are 30. Then in terms of hours, this is basically about 2.2 hours exactly. So to find the average speed, so the average speed, what we get is the distance divided by time. So distance is 30 kilometers. We divide by time, which is 2.2 hours. Then we are going to end up with basically approximately 13.6 kilometers per hour as in the average speed. That's C. Question C. We move to D. Calculate the average speed of the whole journey. So the whole journey, again, we need to find the speed, which is distance over time. So what's a total distance covered is 58 kilometers. Then what's the total time taken for the whole journey? So the whole journey ends at this point, which is 4 hours. The bus stops moving. Here we just continue recording time, because unless it proceeded it was going to be a stoppage, but this is not a stoppage. This is we're just recording time beyond the journey. So the journey ends here, which is 58 kilometers. So we are using 4 hours. The temptation is to use 5 hours, which is incorrect. Here we are just recording the time, but the bus is not moving because it's not proceeding, it's stationary. So the journey ends here. So basically we have 58 kilometers divided by 4 hours, which gives us basically 14.5 kilometers per hour exactly. So that's how you answer D. We go to C. Mention one consequence of overspeeding. So overspeeding basically leads to accidents. So let us look at question B2. State Newton's second law of motion. So this one is straightforward, just to state what the law of motion is, which is the second law of motion from Newton's laws of motion. So this one states that basically if forces acting on an object are unbalanced, they produce an acceleration. In the direction of force. So in the direction of force. So basically this is what the second law of motion states from Newton's laws of motion. We look at B. The following diagram shows a 4 kg box resting on a frictionless surface with forces acting on it as shown. So we have this case. Calculate the uniform acceleration caused by the forces. So for us to answer this question, to find this, we need to use Newton's second law of motion. So first we know that a force is given by mass times acceleration. Then what is this force? So this force should be basically resultant force. So we have in this direction force and this direction force. So we need to find the total force pulling in the left direction and the right direction. So in the left direction it's basically 16 plus 12, which is basically 28 newtons. Then this side is basically 10 newton. So the resultant force will be a force pulling in the left minus a force pulling in the right, which is basically 28 minus 10, which is basically 18 newton is the resultant force. So basically this box will move in this direction. So this is going to produce acceleration in that direction. So now we have resultant force. So this will be the resultant force. So we're going to have 18 newtons equals to basically a mass, which is 4 kg multiplied by acceleration. So to find the acceleration then is just basically this 18 divided by 4, which is basically equal to basically 4.5 meters per second square. This will be the resultant acceleration. So basically this is how you answer this question to get the optimal max. So let us look at question B3. The following diagram shows how energy flows into and out of a coal-fired power station. How much useful electrical energy is produced by the power station? That's question A. So we are looking for useful electrical energy. So if you check here, we have the coil, boiler turbine, then we have a cooling tower, then we have transformer. All these are wastage energy. Then this is 300 joule, which is the electricity produced. So this is the useful electrical energy. So the answer is 300 joules. As simple as that. That's how you get that 1 mark. We move to question B. So B, calculate how much energy is wasted from the cooling tower. So what we know in this case is basically we are pumping in 1000 joules of coil energy, then we are wasting 70 here, then here we're also wasting energy at the cooling tower, but we don't know, we shall call it X. Then basically a transformer we are wasting 30 joules, then we are only producing 300 joules. So basically to find X, we just add 70 plus X plus 30 plus 300 must equal to 1000. So basically it becomes now 1000 basically a joule of coal pumped in must equal to basically the 70 plus, so 70 plus, this is 70 plus this X which is wasted, then plus 30, so plus X plus 30 plus the 300 which is produced. Okay, then basically we have a 1000 joules is equal to 70 plus 30 is 100 plus 300, we have 400 joules plus 30 plus X must equal to 1000. So basically 1000 joules minus 400, when this one crosses the equal sign, is equal to X. So X basically is equal to basically 600 joules. So 600 joules is basically the energy wasted at basically this stage, which is the cooling tower. So that's the answer. C, calculate the efficiency of the power station in producing electricity. So remember, efficiency is basically equal to basically output over input times 100. So basically percent. So basically this is efficiency is equal to basically we are only producing 300 units of electricity by inputting 1000 joules. So basically in this case it will be 300 over 1000. Remember these are joules, all of them, then multiplied by 100%. So what you notice here, this joule and this joule goes 0 0 0 0. Then basically we have basically 300% divided by 10, then we end up with here basically 30%. So 30% is basically the efficiency of this power station in producing electricity. Let us look at question B4. Question A, define convection. So this is straightforward, just to state what it is. So when you're talking about convection, we're talking about basically the transfer of heat energy by the circulation of fluids due to temperature differences within it. So it's the temperature differences within these fluids that causes basically convection to take place. So what should be noted is basically that convection requires a medium to take place. So without the medium, convection will not take place. That's why convection does not occur in a vacuum, because in the vacuum there are no particles. So that should be also taken note. Then the other methods in which heat energy can be transferred are basically conduction, which is basically the transfer of heat energy through direct physical contact. So these conduction requires objects or solid matters. So you could put a pot on the stove, the plate, when it's hot, it will transfer the energy to the pot, and the pot will cause the liquid, which is water, to start boiling. Then radiation is basically the form of heat transfer that occurs when electromagnetic radiation is emitted or absorbed. So you need to know all those three. Let us look at question B. So question B, basically the following diagram shows an incomplete diagram of convection currents occurring in nature at night. Name the breeze. So basically this is basically when you see what is happening in this case. This is happening at night, so this is basically the land breeze. So land breeze, which takes place basically at night. So this is the case where warm sea air rises and is replaced by cooler land air at night. Then the opposite is basically the sea breeze, which happens during the day. At this point, hot air above the land rises and is replaced by cooler sea air during the day. So this is what you need to know. Then Roman numeral 2 of beam. On the diagram, draw convection currents for this breeze. So basically what is happening in a sea air rises. So the warm sea air is rising. Then it is replaced by basically the cooler land air. So the land air is entering. So this is the circle which is happening. So the land air basically from the land is entering the sea, replacing the one from the sea. Let us look at question B5A. List the components of the electromagnetic spectrum in order of increasing frequency. That is starting with the least, then ending with the highest. So basically what we know is basically frequency increases as you move to gamma ray from radio wave, while wavelength increases as you move towards the radio wave. So basically in this case, the one with the highest frequency is the gamma ray, then the least is the radio wave. So remember, it's just now to list them. So you know how to remember the electromagnetic spectrum is to use basically rich men, which is rich men in Vegas use expensive gadgets. So basically we start with radio wave. So radio waves, then we have microwaves, then next we have infrared, then we have basically visible light, which is basically the light itself where the colors are. Then we have ultraviolet, then we have X-rays, then gamma rays as the last one. So basically in this order we are increasing in the frequency, then on the other hand we are reducing the wavelength, because gamma rays have got the smallest wavelength, while radio waves have got the biggest wavelength. But in this case we are looking at frequency. So this is in the order they increase. So this is the first one, then this is the last one, which is gamma rays. Question B. Mention one similarity among the components of the spectrum. So we are looking for the similarity, so we can list one of them. So one of them is basically the fact that all of them, so all have the same velocity or speed, the same velocity in the vacuum of basically 3 multiplied by 10 to the power 8 meters per second in the vacuum. So in the vacuum, remember, they all have the same speed. Then in case we're asked to mention 2 or more than, there are all are basically transverse waves. Okay, that's number 2. Number 3, you can also say they all carry energy from one place to another. Then number 4, you could say they can be emitted or absorbed by an object, all of them. Then number 5, you could also say they are all obey the wave equation, which says velocity is a function of wavelength and frequency. In that case, basically you are good to go. Number C, mention one difference among the components of the spectrum. So basically one difference is basically they have varying wavelength. We just talked about that in terms of wavelength, the one with the smallest wave length is gamma, then the highest is radio waves. So they have varying wavelength. Then also they have varying frequency. So the frequencies, they are all varying. So these are the things that they have in a difference. So because of the varying frequencies and wavelength, even the penetration power differs. Then we look at D, give one harmful effect of the spectrum. So the spectrum basically carries a number of waves. So if you talk about gamma rays and X-rays, these can damage cells. So gamma and X-rays can damage cells, leading to cancer after exposure. So once you're exposed to too much of these, can lead to cancer. They can damage cells and lead to cancer. Then also, just in case you are asked to give more than one, you notice that also that infrared can also cause skin burn. So it's one of the effect that infrared can cause as the harmful effect. Then ultraviolet can also damage skin cells and also lead to skin cancer, and it can also damage the ears. That's ultraviolet. So just to give form of the possible effects, just in case you asked to mention more than one. So basically this is how you answer question 5 to get the optimal marks. Let us look at question B6. The following diagram shows an ultrasound source sending a sound wave into the human body. The total time for the ultrasound to travel in the bone from X to Y and back to X is 9.0 times 10 to the power negative 6 seconds. Question A. What does the term ultrasound mean? So basically, when you talk about ultrasound, we are talking about basically a sound with a frequency of more than 20,000 Hz. then this is basically the ultrasound. Just to take note is basically the human ear can hear sound with the frequency ranging from 20 Hz to 20,000 Hz. So the sound below or above this range cannot be heard, but the sound above 20,000 Hz or 20 kHz is what is termed as ultrasound. So basically this is how you answer question A. We go to question B. If the speed of the ultrasound in bone is 4,100 meters per second, calculate Z, the thickness of the bone. So basically, if you go there, we are talking about Z is the thickness. Then basically, we are told the ultrasound travel from X to Y, then back to X, and it takes the second, which is 9.0 times 10 to the power negative 6 seconds. Then Z is just the distance between these two, which is the one root. So basically, we know that speed is given by distance divided by time. So to find the distance is basically distance is equal to basically speed times time. So now, because to move from X to Y and back to X is taking this, to move from X to Y, which is Z, it should take half of this. So meaning now we are going to say speed multiplied by half multiplied by time, so that we are only interested in one route, which is from going without going and coming back. Then having understood that, we can substitute. We go to B. So we know distance is equal to basically we have speed, which is 4,100 meters per second, then multiplied by the time, which is basically this one, but half of this. So it will be basically 9.0 multiplied by 10 to the power negative 6 seconds divided by 2, because we are multiplying by this half. Then we proceed to simplify that. Basically, when we multiply, we are going to end up with here basically 4,100 multiplied by 0.00009 over 2, which is this part. Then simplifying this, we end up with basically 0.01845 meters, or basically 1.845 centimeters. So basically this is the value of Z. Then we look at question C. Mention another use of ultrasound other than medical use. So ultrasound is used in a number of ways. One which we can use is basically used in ships to find the depth of the sea bed. So basically this is one of the use. Another use could be, if you are asked to mention more than one, is used to check for cracks. So used to check for cracks in small pipes. So in small pipes that are too small for naked eyes. So where the naked eyes cannot see, you can use ultrasound. Then the other one, you can also use it for prenatal scan to check the development of the baby in the womb. So when you go for prenatal, they use ultrasound. So basically, you can choose one of these uses. So basically, this is how you answer this question. Let us look at question B7. Question A, define diffraction of light. So this one is straightforward, just asking us to define what it is. So basically, when we're talking about a deflection of light, we're talking about basically the bouncing back of the light when it approaches or it's a smooth and polished surface. That's what is. So basically, when the light comes and hits the polished surface like this, and this is the normal, if it cannot penetrate there, it's going to bounce back. So this bouncing back is what we are calling deflection of light. This should be the ray of light. Then you need to distinguish between the deflection and the reflection. So deflection is basically, now we have two boundaries. So we have, let us say this is air, then this is water. So when the ray of light is coming from here, which is less denser, it's at this boundary, which is the normal, is going to bend towards the normal. So this one is not bouncing but bending towards the normal because it's moving from a less denser to a more denser. This is reflection. So know the difference between the two. While this is reflection. So basically, you need to take note of that. We go to B. The following diagram shows a dog and a cat standing in front of a plain mirror. Using the diagram, show by construction how the dog sees the cat's image. So remember, the dog is looking in the mirror, so the dog is going to see the cat behind the mirror. So the cat image will be somewhere here, such that this distance and this distance will be the same. That's one thing. So now for you to draw the diagram, what you need to do is basically you need to use a ruler and construct the rays. So the rays will be moving from the cat to the dog. So we draw like this layer, it's the mirror at this boundary, this is the normal, then we'll bounce back like this. Then we have another layer, it's the mirror at this normal, then bouncing back. So these, so the dog looks at the cat. Then the protruded lines will be like this. These will be the protruded line in such a way that they meet somewhere here where they are meeting, and this is where the image will be formed. So use a ruler to draw nicely these rays like this. So basically, this is how you answer the question to get basically the optimal mark, and this will be the image of the cat here, somewhere here. So basically, this is what you do. We go to C. Give two characteristics of the images formed by the plane mirror. So we're looking for the characteristics of the images formed by the mirror. So one, basically we know that the image formed is virtual, it's not real. So basically based on that, then you can say the visual image. So visual image is basically applied. So applied in the sense that if this is in this, and this will be like that. Then number two, basically the image, the virtual image formed is basically the same. The virtual image is the same size as the object. So if the object is 10 centimeter in terms of height, then the image will also be 10 centimeter. That's what it means. So these are the two that we can give, but in case we ask to give more than two, you can also say that the distance of the object from the mirror with distance is the same as the distance of the virtual image from the mirror. That's number three. You can also say that the visual image formed, which is in this case the cat, is literally inverted. So that is to say basically the right hand side will be the other side. So if you're looking in the mirror, the right hand side will match the right hand side, then the left hand side will also match in the way they face each other. That's what it means. Let us look at question B8. The following diagram shows a graph of a voltage against current of a conductor. Question M, what is the maximum current through the conductor? So basically, and this is 1 mark, we just look at the graph. So we know that on the x-axis we have the current in amps, then we have voltage on the vertical axis, which is the y-axis. So for us to determine what is the maximum current through the conductor, you notice we need to see how the graph. So the current is increasing. When it reaches at 3, there is no further change in the voltage. So what it means in this case, basically beyond this the bulb is not going on. So basically the 3 is the maximum. Beyond this 3 is either the bulb is blown up or something is has gone off, so there is no further current. So the maximum current there in this conductor is 3 amps, which is 1 mark. We go to B. Calculate the resistance of the conductor when the current was 1.0 amps. So basically, again, we come here, we look at B. We are asked to calculate resistance, and we know that a resistance is given by basically voltage divided by current. So we need to just go on the graph and look for where current, when current is equal to 1, what is the voltage? So voltage, we come here, then we check here, this is the middle of 0 and 2, so this should be 1. So basically we have 1 volt divided by 1 amp, then we end up with basically 1.0 ohms as the resistance. So basically it's 1.0 ohms. Then we proceed to the next question, which is C. Calculate the power in the conductor when the voltage was at 6 volts. So we know basically power is given by the product of voltage and current. So power voltage multiplied by current. So we know that the voltage is 6, so 6 multiplied by, we need to find current when the voltage is 6. So when the voltage is 6, what's the current? Current is basically 3. So we come here and 3, then we multiply, we end up with 18.0 watts. So this is basically the power in this conductor. Let us look at question B9. Define nuclear fission. So this is straightforward, so just need to say what it is. So nuclear fission is the splitting, so it's a splitting of a large atomic nucleus into small nuclei, followed with the release of energy. That is what we call nuclear fission. So the splitting. Then nuclear fusion is the coming together. So we bring two small nuclei to form a large nucleus. That's fusion. Then fission is a splitting. We look at question B. Uranium 235, when bombarded by a slow moving neutron, disintegrates into barium and krypton plus 2 neutrons. What term is used to describe the products of nuclear fission? So the products of nuclear fission, basically here is the term. What are they called? So these are called as fission fragments. That's what they are called. Roman numeral 2 of B, given that the products of this reaction are 144 mass number and atomic number 56, which is barium, and krypton 36, respectively, in terms of mass number and atomic number, plus 2 neutrons. Write the equation for this reaction. So basically what we are told from here is basically we are bombarding barium with a moving neutron. So basically the equation would be basically to start with uranium, which is 235, then 92, then this we bombard it with 1 neutron, which will be positively charged. Then we end up with 144 barium, then 56, then plus 90 krypton, then 36 here as atomic number, then plus we are told that it plus 2 neutrons. So we are going to have basically 2 neutrons like this. This will be the equation. So what is key is to note that here we need to have this neutron, then this side, then it becomes simple. So what you notice, this is balanced. If you say 144 plus 19 is basically 234 plus 234 plus 2 there, which is 2 times 1 is basically 236. Then this side 1 plus this is 230, so it's balanced. Then here of course we have a 92 here, then that 92, and the other side 56 plus 36 is basically also 92. So this is balanced. Let us move to C. Mention one harmful effect of fission reaction. So if you look at basically the effect, so you notice that basically during this process basically there is radiation. So radiation emitted during the reactions, which is the fission reactions, is extremely dangerous or harmful to humans and the animals, as if not handled carefully can cause cancer. That's one of the side effect of radiation. So this radiation need to be handled with care. Once handled with care, it's good, but if any leakage, it can be catastrophic to the environment. It can cause severe cancer. D. Give one advantage of nuclear reactors as a source of energy. So if handled carefully, this can be a source of alternative clean energy, because there is no pollution. We feel the energy generated from this kind of reaction. So basically this is how you answer this question to get the optimal marks.